Alrighty, welcome to Module 4, Lesson 13, the problem set. And in this problem set, we are going to analyze and classify triangles based on length, angle measurement, or both. So let's get started. All about triangles. All right, so number one, it wants us to classify each triangle by its side lengths and angle measurements. Circle the correct names. Well, when we look at the first one, we're looking at, well, the side lengths. Now remember, for side lengths, it's either going to be an equilateral triangle where all sides are the same length, isosceles where two sides are the same length, or scalene where none of the sides have the same length. So if we look at the first one, the indication with the tick marks here and here indicate that those two sides are equivalent. And since they're equivalent, when two sides are equivalent, that is an isosceles triangle. So we'll circle isosceles. And then the other one is, well, when you look at the angle, with an obtuse, you can only have one angle be obtuse in a triangle. And we see it's not a right triangle, or there's two acute angles, but if there's at least one obtuse angle, the classification is obtuse. You say, well, wait a minute, I see two acute triangles. Yes, there are two acute, but if you have even one obtuse, it is an obtuse um, a triangle. So there you go. Now let's look at the next one. On the next one, well, why don't I go ahead and pause it and you give them a whirly-durly. Alrighty, how'd you do? Well, the B, all three sides are the same, and that's where you get that kind of looks like a word equal in there. So they're all the same, so that one is an equilateral triangle. And here's a little fun fact. Equilateral triangles are always acute. Why? Because all three angles are, dun, 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 they're all 60-degree angles. All three of them are 60-degree angles. Okay, and then the next one is scalene because all three are different lengths. And it's a right triangle because this symbol here, that means it's a right triangle, which is how many degrees? Oh yeah, 90. And then on the last one, none of the sides are the same length, so it's scalene. And this angle right here is obtuse. So there you go. Let's get on to the next section. All right. Number 2, triangle ABC has one line of symmetry as shown. What does this tell you about the measure of A and C? Let's think about that. Well, angle A must be, angle A is equal to angle A is equal to angle C. Okay? And if you fold it over, because if you fold it over, they'll match up completely. Okay, so let's continue on. That way, just put if you fold it, the sides will match up with angle A and angle C. You fold it right on the line of symmetry. Okay. Well, angle DEF has 3 lines of symmetry as shown. How do the lines of symmetry help you find out which angles are equal? Well, let's see. How could we use those to help us figure it out? Well, if you fold them over, I'm just thinking about this out loud. If you fold this over, then that means F, okay, so F, that's going to equal D. If I fold it right down E, okay, and then if I fold it along F, this line, okay, let's just color code this so we can kind of see what's going on here. So if I fold it right along the E there, then D and F are going to show up. But what if then I change to blue here, and I'm going to fold this line of symmetry here? Well, then this E will match up with D. So wait a minute. And then let's see if we have one more way to do this. We could use, let's just use black. And we go ahead and we fold it along this line here. Then that means this one has to be equal with this one. Well, what we've just kind of proven is that all 3 of those angles will be the same length. Very interesting. So what we've proved is that all 3 angles will have the same measurement. And we could conclude too, if you look at this, we can conclude that this is an equilateral triangle. So all the sides are also equal length. And the conclusion that I've come up with is this is an equilateral triangle. It's an equilateral triangle. Equilateral triangle. There we go. Alrighty, let's keep on rolling and look at part B of this question. And question B says that DEF has a perimeter of 30. Label the sides. Okay, well, we just said that they have equal length, so they're all going to be, it has a perimeter of 30. So something plus something, so we have x plus, let's use a different color. You can't even see that. Let's go to, okay, so we'll say x plus another x plus another x is equal to 30, and all of them are going to be the same. So we can say that they are 10 centimeters, 10 centimeters, and 10 centimeters. All right. Well, this is a little complicated, but I think we got that one. So let's go to the flip side. All right, welcome to the flip side. What are we going to do here now? It says, use a ruler to connect points to form 2 other triangles. Use each point only once. None of the triangles may overlap. 1 or 2 points will be unused. Name and classify the 3 triangles below. The first one has been done for you. Okay, so I guess we can do any ones we want. So, all right, well, okay, it says we need to do 2 more triangles. All right, we'll connect A and B, and I'm just going to do an ABC triangle. Okay, I'm do an okay, ABC. I got a triangle there, and I want to make another triangle. All right. I can use any of these I want. Well, I'm going to do an ED. I'm going to go HD, and I'm going to go ahead and connect these two. Alright, there we go. And so I've got 2 triangles here. And I noticed on this one, that was a right angle. So now I can go ahead and classify my 3. Oh, I should have had you pause it, and you could have figured out your own triangles, because they don't have to be exactly like mine. But if we did use these, we can use the classifications down below. And the classifications on the first one was done for us. It was a scalene and obtuse. And I've got triangle ABC. And my triangle ABC is scalene. It's scalene and it is obtuse. And my other triangle, EDH, triangle EDH, is a right triangle, and it is an, oops, I'm supposed to put the right over here. The right goes over here, and then in this side, I'm supposed to put that it is once more scalene. All my triangles are scalene. None of them are equal length. Okay, so this one is also a scalene. Okay, all right, and then let's continue along. Okay, so 5. List 3 points from the grid above when connected by line segments do not result in a triangle. Well, let's see. Well, I see one. If we connect points, let's see, 3 that don't make, well, there's different ones that won't make a triangle. If I connect, let's see, this says 3 points, because usually 3 points make a triangle, but if I were to connect, let's see, G, oops, well, if I did G, F, and then I did F, K. So if I did points G, oops, well, let's get our pen back here. Okay, correct that. If I did points G, F, and K, would not make a triangle. Okay, G, F, and K would work. Also, I could do G, I, and H, or G, I, and H also work. Okay, so those all work. Either one of those. Okay, and why don't the 3 points you listed? Because when you connect them, they make a straight angle. Those 3 can make a straight line, or make a straight angle. Okay, so okay, let's scroll that down just a little bit. Okay, why don't they make a triangle? They make a straight angle or a longer line segment. Okay, there you go. And then the last one, can a triangle have two right angles? Well, think about this. There's one. Now, how can I make one of, if I were to make either one of these a right angle, it wouldn't connect. So the answer is no, because because if you had two right angles, there would be no way to connect the sides. There you go. Well, there you go. Your problem set is done. Whew, that's a good feeling. Now all that's left to do is, oh, that's right, homework. Oh well, you know what they say, homework is done at home. Catch you next time, same place. Hasta la vista, baby. Psst, it's over. Get to work.